Lesson 5.3 today, we're talking about medians and altitudes. So, I'm going to tell you right now, we're done with actual theorems. Okay? We're learning these two vocab terms today, and then we're doing actual math with them. Okay? What does it mean to be a point of currency? Concurrency, sorry. What's a point of concurrency? What's that mean? Where they meet, right? It's a point at which all of the lines meet together. Okay? I want to look at this picture on the front of your notes real quick. What can you call these lines right here? Let me do a different color. Are these perpendicular bisectors? Is that line a perpendicular bisector? Let's talk about what a perpendicular bisector is. What's the perpendicular part? 90 degrees. What's the bisect part? Splits it in half. Okay, do we have both of those things?
Yeah.
We don't have a 90-degree angle, okay? We do not have this 90-degree angle, but what does this mean? They're congruent, which means it's split in half, right? So can this be a perpendicular bisector? No, because we don't have the right angle, okay? This is a median instead, okay? It's a median, okay? So can we call, you already answered this question, okay? Answer it again, though. Can we call these lines perpendicular bisectors? No, because there's no right angle, okay? Cannot call those a perpendicular bisector because it does not have a right angle. So last week we talked about the concurrency of perpendicular bisectors. Okay, if that was true, then we could say that these lines were the same. But since they weren't perpendicular bisectors, can we assume that? No. Okay, remember, if you don't have the if, you cannot have the then. Okay, go ahead and flip your notes to page 2. I'm going to have you write 2 definitions down. Okay, and I'll write them up here so you can follow along. Okay, write them in the margins of your example 1 over here. Okay, 2 definitions for today. First one we're talking about is altitude. Okay, so altitude, write this definition down, is a perpendicular segment from a vertex of a triangle to the line containing the side opposite the vertex. So again, with these definitions, okay, you know what all of these words mean. Okay, what does perpendicular mean? Right angle, 90-degree angle. Okay, what's a vertex mean?
What 2 lines mean?
Right, how many vertices does a triangle have? 3, it's the corners, right? A is a vertex, D is a vertex, and C is a vertex. Okay, so what altitude is saying, or what its definition is from a vertex, I'm going to say A, okay, from vertex A to another side, okay, they extended this side over here, okay, to this opposite side, creating this 90-degree angle, okay, that is an altitude, okay, so from a vertex to the opposite side, okay, that is an altitude, creating that right angle. I want to ask you this, what is the difference between an altitude and a perpendicular bisector? What do they have in common?
They're perpendicular.
The right angle, right? What do they not have in common?
Altitude doesn't have a bisector.
Right, altitude does not bisect a side. Okay, altitude, all it has is from a vertex to another side creating a right angle. Perpendicular bisector, it does not have to be from a vertex. Okay, perpendicular bisector does not have to be from a vertex. Okay, questions about altitude. So altitude, you're just looking for that right angle. Okay, next one and last one for today is a median. Okay, what do you think of when you hear the term median? Middle, right? Exactly. Okay, so median of a triangle is a segment that has endpoints at a vertex and the midpoint of the side opposite the vertex. So again, with these definitions, you know what these words mean. Okay, they're just putting them together for a new definition. Okay, so median, we all said middle, which I agree. Okay, what is a vertex again? It's like a corner, right? How many vertices does a triangle have? 3. Okay, so the one they're looking at, let me erase my picture real quick. What they're looking at this time is that BD is a median. Okay, do you agree that D is a vertex of that triangle? Do you agree D is a vertex? Okay, because it's where 2 sides meet. Okay, BD is a median because it splits this side in half. Okay, B is the midpoint of AC. Okay, I'm going to ask you this. How is DB, or how is the median, similar and or different from a perpendicular bisector? It splits a side in half, right? What does a median not have that a perpendicular bisector has? The perpendicular, right? The right angle. Okay, so kind of see how these are parts of a perpendicular bisector. Okay, altitude, what do you need to be an altitude? The right angle, right? Median, where is that point at? Middle. Okay, it's at the midpoint. Okay, on example 1, I want you to tell me on A what the altitude is. So tell me the line that is the altitude, and tell me the line that is the median. I want you to label the altitude and the median. Okay, which one is the altitude? CE. Okay, why is CE the altitude? What was the dead giveaway? Right angle. Okay, make these notes so you know for later. CE is the altitude because of that right angle. Okay, it goes from the vertex to the opposite side, creating that right angle. Okay, so what is the median? BD. Can you also say DB? Yes. Okay, it does not matter the way you write it. What gave it away that BD was the median? Splits the side in half, right? Okay, so BD right here is the median. What is the midpoint of AC? D, right? Yep. Good. I want you to copy the outside of that triangle on part B. So just draw the outside. So you have triangle A, B, C here. I'm going to draw a new altitude and a new median, and I want you to label them for me. Label the new altitude and the new median off of that picture that I just drew. What is the altitude of this triangle? Oh, I forgot to give you letters, didn't I? Now what's the altitude? AE, what was the giveaway? Again, the right angle. Okay. What is the median? CD, again, giveaway. It's the middle, right? It splits that side in half. Okay. You do not have to write this down unless you want to. Okay. Can I call this line right here an altitude? Can this line be an altitude?
No.
Why not? Has to be coming from the vertex. Okay, so what that means is the opposite side of the right angle has to be coming out of a corner or that vertex. Okay, so this here can be an altitude. Same thing with a median. Okay, can I call this a median? Why not? Has to be coming out of the vertex. Okay, so keep that in mind. Questions about those two things? Looking at this here, okay? These are all medians. Do you agree? All of these lines in here are medians. What is this point called in the middle? Where they all cross. Or they all meet? Point of concurrency. Good, okay? Remember, concurrency is where they meet. The point of concurrency is the point where they meet, okay? We are going to start to put math with this. I want to focus on this line right here, this CF. Everyone see that? Okay, CF. Which side, do you agree there's two parts of that line? This right here is a part and this here. Okay, which part looks bigger? Top or bottom? Top looks bigger. By how much? If you had to write those two things as fractions. What?
No, it's
1/3 and 2/3.
It is 1/3 and 2/3, okay? So this is 2/3 and this is 1/3. Whenever you're working with the medians, it's always going to be 2/3 to 1/3, okay? What is an equation that I can write about that line? I'm going to give you a hint. What can I write for CG? What's an equation I can write for CG? CG is 2/3 of what? The whole thing, right? I'm just going to say CF, okay? CG is 2/3 of CF, okay? That part is 2/3 of the whole thing. What is an equation I can write for GF? GF is this one. 1/3 of CF, okay? I want you guys to write in the margins of example 2 is fine. Write me an equation that describes line EB. Write me two equations that can describe EB. To get you started, which side looks the longest? Side B, right? So this is your 2/3 side and this is your 1/3 side. Write me two equations that look similar to those two for that line. Okay, someone give me one equation that you came up with.
2/3 of BE.
What is 2/3 of BE? GB, right? Good. What's the other part of that equation? EG equals 1/3 of BE. Okay, are these equations making sense?
Yeah.
Okay, so like I said, it is always going to be 2/3 and 1/3. Okay, and it will be obvious to which side is the larger side. Okay, so let's put that with this example here. This one's not in your notes yet. Okay, let's do this one as an example. So we're looking for the length, or what it wants is the length of JN. Okay, so first thing you want to do is pick which side is the longest side. The side of J. So JQ is 2/3. What's QN? 1/3. Okay. So we want to create an equation. Now, I'm going to take us back to proofs. Okay. When we were writing proofs, what was the first thing we always looked for? The givens, right? What did they give us in this one?
18.
They gave us this, right? So we want to use, let me use a different color. We want to use these two numbers to help us figure out this equation. Okay, so how can I write an equation using those two facts right here? That's okay. We want to find, let's start with JQ. Do you agree they gave us what JQ was? Okay, JQ equals what? 18. Okay, what's another equation I can write for JQ?
2/3 of
Yes, JQ is 2/3 of JN. How can we use those two equations to solve? We need to focus on this one right here. What does JQ equal? 18. So 18 equals 2/3 of JN. Can we solve that?
Yeah.
Okay. How many of you do not like fractions? Okay. Whenever you have fractions, you want to get rid of them. How can I get rid of that 2/3?
3.
Multiply by that denominator. Multiply by 3 on both sides. So that gets rid of these. What's 18 times 3? 54 equals And what we have left is 2jn. And then what's my last step to get jn by itself? Divide by 2. So jn equals 27. Okay? Yes, that is what it wants. Okay, this whole thing is 27. So if I know this is 27 and JQ is 18, how could I find what QN is?
27 minus 18.
I could subtract it, right? Could I have made an equation that looks like this, just with the 1/3? Okay, but do it the easier way. 27 minus 18 would give you 9. Okay, 2a together. Let's walk through this again. Okay, it wants us to find, the directions say, find the length of AD. Okay, finding the length of AD. We want to figure out the larger side and the smaller side. Which side is going to be my 2/3? Yep, so label that side as your 2/3. The other side is your 1/3. Always start with what you're given and you want to work with that. Okay, what is an equation I can write to help us solve? Start here. They gave us AE, right?
Equals 2/3.
Right, AE equals 2/3 of AD. So now fill in what you know. Do we know what AE is?
Yeah.
What is AE? 21 equals 2/3 AD. Go ahead and solve that. All right, what would be your first step to solving this? Right, we don't like fractions. Get rid of them. Multiply by 3. What is 21 times 3? 63 equals 2AD. Last step. Divide by 2. AD equals 31.5. Good. All right, go ahead and try part B on your own. Okay, with problems like this, what should we do first? What'd you say? Right, we want to figure out what our largest side is and what our smallest side is. What's that? Which side's 2/3? AE, which means the other side is 1/3. Okay? Always look at what you're given. Okay, so they gave us this information right here. How can I set up an equation with that information? 12 equals 1/3 of the whole thing. Okay, so how would I solve this? Multiply by 3. What's 12 times 3? 36 equals
180.
AD, right?
Yeah.
Okay, so that's AD. How can I find what AE is?
36 minus 12.
Right, all I would have to do is subtract. 36 minus 12 is
24.
24.